Hey everybody, Middle Mind here, and in this video is where the fun really begins. Because before now, all you've been doing is watching me show you guys some of the stuff I built, and who really cares about that? What's going to be a lot more fun for both me and you is us going through this next series of tutorials and having me teach you how to build your own crazy and awesome contraptions. So what we're going to talk about in this video are two what are called logic gates, and you should think of a logic gate as a machine that has a series of inputs that are all either on or off, and a series of outputs, which are all either on or off. Now, these machines come in all different shapes and sizes, so you could have a machine with one input and one output, a machine with two inputs and one output, a machine with three inputs and 8 outputs. Whatever you can dream up, it would still count as a logic machine, as long as every input is either can only be on or off, and every output can be only on or off. So the two basic logic gates that Notch has allowed us to create in Minecraft, one is called the OR gate, and the OR gate has two inputs. So we would put two dots here representing these inputs, and then these torches will show our way of representing whether the inputs are on or off. Now the way the OR gate is built is by connecting these two dots into a more uniform wire and then giving it an output. And now the reason this is called the OR gate is because the output is on when this input is on, the output is on when this input is on, and the output is on when both inputs are on. Now this last one might seem a little bit confusing because it kind of contradicts the idea of an OR statement. It's sort of like, well, it's one or the other, but not both. But in mathematics, OR has a very distinct meaning. Namely one that in mathematics, OR is always a yes or no answer. So if I were to ask you if you are left or right-handed, in math speak you would just reply yes, because it is true that you are either left-handed or right-handed. It's all one statement. And as well, if I were to ask you if you were a human or if you lived on planet Earth, you would again say yes, because both things are true, and in math you say yes when both inputs are true. So that is the first logic gate we're going to take a look at in this video. And the second one is called the NOT gate. The NOT gate is a logic gate with one input and one output. So we put the input here, and then we place a block here and a torch there. And so this is all it takes to build a NOT gate. Again, these are both pretty simple contraptions. It's not until we start combining them together in funky ways that things will start to get complex. So with the NOT gate, as you might have guessed, it sort of negates whatever the signal is. So if the input is off, then the output is on. And if the input is on, then the output is off. The reason why this works is simply because that is the way that Notch designed Redstone to work. So these are the two ones that Notch has blessed us with. And from that, we can sort of build everything else on our own. Now, for the rest of this video, we're going to get a little bit mathy and get a little bit of a deeper understanding of sort of what's going on here with these logic gates and these inputs and the outputs. So a good way to represent a logic gate is through what is known as a truth table. And you could think of a truth table as sort of a very basic type of graph. Well, I sort of don't even want to call that, because it's sort of how you have when you're graphing a function, you graph the x versus the y in sort of like an input-output type of situation. So here it's sort of the same thing with, you have a series of inputs. However, the inputs, instead of being sort of any number you want, they can be only on or off. So the variable here, p, is often used in logic to denote some logical statement. So p could mean that it's raining outside, p could mean that elephants are pink, it can mean whatever you want. Or you could also think of it in the context of Redstone as a variable that is either true or false. So the way we use these truth tables is first by listing all the possible values of the input. And here, since we only have one input, the input can be only on or off. So this T here stands for true, and it's the way logicians think of the input being on. And here we have the F, which stands for false, which logicians use to say if the input is off. Now over here we have the output column, and the sideways looking L thing is math speak for not. So in mathematics, people are often really lazy, and if they can ever find a way to save themselves some time by changing a word to a shorter symbol, they'll do it. So instead of writing not P, they decided to save themselves some time and invent this new symbol, which literally means not. So in your head, you should read this as not P. So this is the output. And as we can see that when the input is on or true, the output is off or false. And when the input is off, the output is on. Or again, if the input is false, the output is true. Now we take a look at the truth table for our OR gate. And so again, just real quick to get through the math speak, this sort of V-looking thing is what mathematicians use to denote the word OR. Again, just to save themselves some time so they don't have to keep writing OR over and over again. Now, this one has two inputs, so there's a little bit more possibilities for what the total input could be. So we could have one possibility is that both P and Q are true. Another possibility is that P is false and Q is true. Another possibility is that P is true and Q is false. And the last possibility is that both are false. Now, as we talked about earlier, the output is going to be in this column. And as we studied from what we know about the OR gate, if both inputs are on, the output is on. If either one of the inputs are on, then the output is on. And if both outputs are off, then if both inputs are off, then the output is off as well. So these truth tables might not seem so significant now, but they're really going to come in handy when we're building up bigger and bigger logic gates, because they'll help us get a better handle on what's going on, and it'll help conceptualize some things later it'll make it more easy to understand. And that's pretty much all I got for this video. In the next one, we're going to take a look at some of the more advanced logic gates you can build using these two, namely the AND gate and maybe some other ones if we have time in that video. So hope you enjoyed, and see you next time.